Okay, question 5 for an introduction to statistical learning. If you're following along here in chapter 2, this is chapter 2, question 5, and if you are following along, this question feels a little bit like we're beating a dead horse, so I'll be a little bit more brief. So if you check out the earlier videos, and maybe specifically the answer from the answer video from question 3, you'll get a little bit more information here. But here we are asked to discuss the advantages and disadvantages of more flexible versus less flexible approaches to analysis, to regression or classification. And when might more flexible be preferred over less flexible, and vice versa. Okay. So again, this has been covered quite a bit here in this sheet and in the previous videos, so I'm not going to go super in depth here. Check those out if you want more. So, but roughly, the flexibility of a model can be both good and bad. So if our data is complex or represents complex phenomena or complex relations amongst the data, then a flexible approach allows us to model, or potentially allows us to model, that complexity, or some of that complexity, or more of that complexity than it would if we had a less flexible model. Okay, and so the extent to which we are accounting for, or at least can account for, some of the complexity in the data, we are reducing bias, which again is one of the causes of error in any of our analyses. Okay, and so the flip side of that is if we have less flexibility than what the data may call for, well, then we are increasing the bias of our analysis. Okay. Now, the unfortunate thing is that we don't, almost by the very definition of why we've come to collect data, which is we don't really understand the phenomenon about which we're collecting data, we don't know the appropriate level of complexity in a model. And so it's not really clear. We have some methods that we'll encounter that help us try to guess how complex the data is and therefore how flexible our model should be, but we don't know that level exactly. And so this allows us, or this means that we might underdo the flexibility of our model, therefore increasing bias, but we can go too far the other way. We can be too flexible. And when we're too flexible, we add variance to our analysis, right? So in other words, so again, what is variance? Variance is this idea that if we were to use a different data set but from the same population, the analysis would spit out more different answers, even though they should be roughly the same answer. Okay, so if we have too much flexibility, we introduce too much variance into our analysis. So we might want to use flexible methods when we have a lot of data, because complex relationships within our data can be better explicated if we have lots of data. Okay. And also, if we may tend to want more flexible methods if we are concerned with making predictions, right? So if we want to know whether the stock market's going to go up or down, or how much it's going to go up or down, we kind of don't care how third quarter sales of Nike tennis shoes, is going to affect the stock. That's not really important to us if the answer, or if the question that we want to know is, what is the stock market as a whole going to do? If that even makes sense. I'm not a financial guy, but on the other hand, if we don't have a lot of data, we need to use less flexible methods, again, because there's less data to explicate the complexity within the data set. Okay? And also, even if we had a lot of data, we may still tend to choose less flexible methods than we otherwise might if we want to infer the relationships between predictor variables and outcome variables, right? If we have a lot of variables in there, and if we're using a lot of predictor variables, all of those predictor variables, they have their own relationships. And so it can be hard to, well, two things. It can be very difficult to just keep in your head how all of these different predictor variables are relating to the outcome variable. But also, the relationships amongst the predictor variables can cause very weird inferences with how any particular predictor variable affects or is related to the outcome variable. If you want more than that, you should check out my Statistical Rethinking playlist and Richard McClarett's book, Statistical Rethinking. It has a lot more to say about that. So anyway, that's it for this one. Thanks.